Hello, my name is Jonathan Kim, and today I'm going to be talking about gas metal arc welding versus hybrid laser assisted gas metal arc welding. Hybrid laser assisted gas metal arc welding consists of two processes, gas metal arc welding and laser beam welding. The first of these processes that I'm going to talk about is gas metal arc welding. Gas metal arc welding is a very common process used for welding today. It is actually the most common used welding process for robotic welding. Gas metal arc welding works on mainly two principles. One of those, it has an electrode that is continuously fed out of the nozzle. As that electrode reaches the electric arc, it melts and drips down into the fusion zone. Another one of the main principles of gas metal arc welding is the shielding gas, which spreads out and protects the weld. That also comes out of the nozzle. There are many benefits of gas metal arc welding on its own, and those include that it's suitable for welding most ferrous and non-ferrous materials. It is a very efficient system. This is due to the high deposition rates and the high electrode efficiencies. It can also create extremely long welds. This is mainly because of the filler and electrode that is continuously fed through the nozzle. It also has very minimal post-weld cleaning because it has no slag that is created during this process. Because of this, you can pretty much just roll with it. The weld is pretty much ready to go once it's complete. And as I mentioned before, it's an easily automated process. That's why it's one of the most common ones used for robotic welding in today's industries. There are also many negatives to gas metal arc welding. The main one is that it can only handle moderate levels of surface contaminants. This is common for most welding processes. So if it encounters things such as rust, mill scale, dirt, oil, or paint, it could potentially incur porosity or also bad bead appearances, or cracking could occur. And these are all bad things that could happen to the weld itself. Wind is also a problem that is somewhat unique to this form of welding, and that is because the shielding gases can get blown away by the wind, and that would potentially cause problems for the weld as well. As with most forms of welding, safety is a potential hazard for the user due to the UV rays that are harmful that are produced via welding. Another major thing is that it's only suitable for thin materials, and this is because it has relatively low temperatures that can be achieved by this process. So that means that the melting of the material can only penetrate very shallow into the base material, and this is a problem, one of the major problems associated with this form of welding. So the next process that I'm going to talk about is laser beam welding. This is a pretty cool process because it's an autogeneous welding process. That means that it has no filler, which leads to some of its major downfalls, but it's a very efficient system. Some of the many benefits of this are that it can be used for a variety of materials. It is also a deep penetrating, so it can penetrate a lot deeper into the material when compared to the gas metal arc welding process. It could also produce a very good quality and high strength and ductility of the weld. This is mainly because of the minimum shrinkage and distortion due to the very small heat affected zones that are created by the laser itself. And this also leads to it being relatively free of porosity, which is a major component of having a good weld. Another major thing is that very fast speeds can be achieved when using laser beam welding. It's just a very quick system and can be automated to produce welds at a very high rate. Another major thing is that no electrode is needed for laser beam welding processes. There are a lot of negatives associated with laser beam welding. One of those is that there are a variety of safety hazards associated with it, particularly involving the laser itself. If it comes in contact with the eyes or skin, that could be a major injury risk. Another thing is that high costs are associated with this form of welding. Anything The initial cost is extremely high, the maintenance costs are high, the power costs are high. It's pretty expensive all around. Rapid cooling is also something that can be experienced due to this process. This is because it has high heat in a relatively small area, so the heat does not transfer well to the heat transfers relatively quickly to the rest of the base material, and it cools very rapidly. Another thing is that high skilled labor is often required in order to run this equipment. Another thing is that it has a very small spot size, and this means that the laser is very focused and can only impact a very small area. This can lead to very poor bridge gapping capabilities, and it also has an inability to provide adequate reinforcement due to a lack of a filler. Yeah, so whenever you combine both of these two processes, the gas metal arc welding and the laser beam welding, you get the hybrid laser assisted gas metal arc welding process. So as you can see, it's pretty much just a regular gas metal arc welding process with a laser also focused into the same fusion zone of the weld. So this allows it to get a lot deeper into the weld, and it also has a lot of other benefits. Some of these benefits are that it has a very narrow heat affected zone, and this is the zone that is traditionally the weakest part of the weld. So by reducing the size of it, it will drastically increase the strength. It also has a very deep penetration due to the laser beam welding portion that is contributed to the hybrid. And as you can see, it has an increase of 10 to 20% compared to the laser beam welding, and an increase of 20 to 50% due to the gas metal arc welding processes. The laser beam welding also helps contribute to a lot higher of a speed for the overall hybrid process. And for an example of this is that there was a 2 millimeter thick aluminum alloy that was tested, and for the gas metal arc welding, it took a 0.95 meters per minute. For the laser beam welding, it was 3 meters per minute, and it was able to increase all the way up to 5 meters per minute for the hybrid laser gas metal arc welding process. Also, one of the things that the laser beam welding process alone was very poor at was the bridge gapping capabilities at 0.3 millimeters. The gas metal arc welding process was a lot higher at 1.05 millimeters, but whenever you combine them, you can actually get up to 1.19 millimeters of bridge gapping. This is very useful for bridging large gaps. Overall, it also has a much better efficiency than the individual processes that make it up. This is because it requires a lot less heat input to melt the same volume of material. And by lowering this heat input, it lowers the amount of distortion that is experienced by the material, by the weld itself. It also has much better quality. This is because the lower heat input considerably increases the metallurgical properties of the weld. The economics of the hybrid laser gas metal arc welding system are actually very good in terms of being compared to a traditional laser beam welding process. The main savings here actually occur from the laser itself. This is because the power consumption is much less whenever it is in the hybrid state. The reduction in power can be between 1 to 2 kilowatts for the laser itself, and this translates to between $130,000 and $260,000. So the addition of the gas metal arc welding system is approximately $40,000. So that's an increase into the cost. So a net reduction to the overall cost is about $220,000 at its max. Another way that it can increase the productivity and efficiency of the whole system is that the increased welding speeds that can be achieved with the hybrid system can reduce the overall cost per component. Another thing is the higher quality can reduce the amount of scrap necessary, so that also has a reduction in the scrap costs, so the overall cost of the system is lowered. There are some negatives with the hybrid system, and one of those is that it's more difficult to shield. This is because of the higher temperatures that are experienced due to the combination of the two two systems, and that can lead to an increase in hydrogen absorption. Another thing is that poor weld bead appearance can be sometimes noticed compared to the gas metal arc welding. Another thing is that large amounts of molten liquid compared to the laser beam welding are present, and during certain techniques that require full penetration welding, it can cause significant difficulties. And another thing is the increase in complexity, which is due to the number of welding parameters that are encountered whenever combining the two systems. Another thing is that the same sort of increased and higher skill level is required in terms of operating this type of machinery. So overall, I think that this is a very beneficial system, especially whenever compared to the traditional laser beam welding, because of the significant cost reductions in that aspect. It does have a much higher, deeper penetration than the traditional gas metal arc welding. So whenever you combine, you sort of take advantage of many of the benefits of them, and you only have a small amount of negatives because each system sort of takes away a few of the negatives of the other one. So overall, I think that this is a very beneficial system, and I think that the hybrid system is the way to go if you have the funds, or if you are looking at a laser beam welding system already, then you definitely should go ahead and upgrade to the hybrid laser assisted gas metal arc welding system. Thank you. I hope you enjoyed the presentation.